Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 13 of the February daily Leetcode challenge, and this is the first time that we are having a question on heap, which is also called as the priority queue. Okay, so let us quickly begin with this question. So I have done a lot of groundwork here, and I will be showing some of the interesting things here. Basically, like, no one will teach you this part, but in the interview, if you are getting this kind of questions, remember these calculations do matter, because like by you are changing it, like using a particular data type by extended data type, you will have to justify that. For that reason, these calculations will matter. I don't think anyone else is showing these calculations, so I will be taking this as the starting point so that you will learn this part also. Okay, so today start with the Java solution, and then eventually we'll go to the Python solution. So this was a basic overview of this whole video, so let us quickly begin now. It is going to be 3066. The minimum operations to exceed threshold value 2. Okay, this is a part 2 of that basic question. So what we are given, you are given a zero index integer array nums and integer k. Okay, as you can see in the book, it's a basic integer array and a value k. All of them are like positive integers here. Okay, yeah, in one operation you will do the following: take two smallest integers x and y in nums. Okay, remember the word smallest means they have to be the smallest among all the numbers. Okay, take the two smallest integers x and y in nums, remove x and y from nums. Okay, so x and y are basically removed from that whole array now, and then instead of them a single element now will be inserted. So try to understand the order here, what is happening. Two smallest elements are removed. Remember, when I say smallest, they really mean the smallest. Okay, so let us say there are 10 elements, so the bottom two will be removed. Okay, once you sort it, the bottom two will be removed. Instead of those two, now a new element will be inserted. So what is that new element going to be? It is going to be this. Okay, so among the x and y, whichever is the minimum, take that, multiply that with 2, and add the bigger one among x and y. Okay, so min into 2 plus max. Okay, that is going to be the number that is going to be inserted. Remember, this whole thing is a single number. Okay, if you evaluate this, you will get a single number that will be inserted. Okay, now next, after this, okay, after this again the same thing will keep continuing. Okay, again the same thing will come. So you, yeah, let's see the question after that. Note that you can only apply the describe operation if nums contain at least two elements. Okay, if there are less than two elements, you cannot apply this operation, because obviously we require x and y both. Okay, if let us say one is missing, obviously you cannot like calculate this one, right? That makes sense. Return the minimum number of operation needed so that all the elements of the array are greater than or equal to k. Okay, so basically you are supposed to do this operation. Okay, till all the elements, okay, present in that particular array are greater than or equal to k. Okay, that is going to be a stopping condition now. So yeah, you can go through this question, but obviously, like as I mentioned at starting itself, this is the exact application of a topic named heap. Okay, many people call it as a priority queue, and if you see the library wise, in Java we have a library for priority queue, and in Python, if you see, we have a library for heap. Okay, so both of them are like same terms, but they're used in different sense. Obviously, there are like slight different, references also, but on an overall basis, like on a top view, if you see, they are acting the same, especially in this case. Okay, so we'll not go for the differences, we'll go for the similarities here. Since this is a very basic question, both of them will basically function the same. Okay, let us quickly see the other aspects of this question. So let us go to the constraints now. See here, constraints are going to play a very important role. Why I'm saying like that, let me quickly explain. If you see, each number here, okay, is going to be in the range of 10 power 9. Okay, this is a very high value, I'm telling you, this is very high. Okay, now if you see this, yep. The okay, K part, okay, K you can, what K means see, idea here is, see, if it see 10 power 9 also, you can basically have a single number within the integer range. Okay, what is the integer range? See, you can 31 bits you can use, and if you are able to store a number within 31 bits, then you can say that yeah, you can have that number within an integer. Okay, 10 power 9 is within an integer, but even k is with an integer, and see the length is going to be 200 by 5. Okay, but here the challenge that is coming, see this part now. See, now please start paying attention. This is the most important part. You are taking an element, you are multiplying it with 2, and you're again adding it back to the element. Okay, now let us see what max can happen. Okay, in the worst case, what can happen? See, this is basically analysis of the edge cases, so please pay attention. Remember, this is going to play a very important role, especially if this kind of questions comes in a review. This is the part that they will be, saying, okay, how you're managing the risk. Okay, see this part. In the worst case, this could happen. See, the value, both the values, let's say at 10 power 9. Okay, so the answer will be 10 power 9 will be removed, and this value will be updated. Okay, 2 into 10 power 9 plus 1. Okay, what I'm doing is, see, instead of x and y, I'm just replacing x and y with 10 power 9. Okay, so these two values will be removed, and the value that will be updated is min of, see, 10 power 9 into 2 plus 10 power 9. Okay, that is the value. Okay, so I'm writing it here, 2 into 10 power 9 plus 10 power 9. Okay, so this becomes 3 into 10 power 9. Okay, now I want to know how many bits will be required to store this number. Okay, so that's why I'm saying 2 power n is equal to 3 into 10 power 9. Okay, this is the approximation equal. Okay, this equal is basically approximation. It's not the direct equal. Okay, so 2 raised to power n is equal to 3 into 10 power 9. Okay, let us apply log on both sides. It will become n log 2 is equal to log 3 plus, okay, log 10 base 10, which will 1. Okay, which is 1. So it is 9 plus log 3 is equal to n log 2. Okay, so 9 plus log 3 becomes 9.47, and this is n log 2 in the LHS. Now if you shift log 2 to the RHS, it will become 9.477 divided by log 2, which is equal to 31.48. Okay, so the value of n is going to be 31.48. Remember, it is crossing 31. Okay, it is crossing 31. Remember, in an integer there are 32 bits, that is 4 bytes, which is 32 bits, and 1 bit is basically used for, it is the sign bit for storing the sign, positive or negative. So there are 31 bits for us to use, and it is crossing the 31 bit. Okay, that means a point will come where your calculations, because of that single bit, you will see basically a negative number in your calculations if you are using only integer. Okay, for that reason, because of only this reason, we will now have to see, idea here is this result you should basically store in a long. Okay, that is the extended int. Okay, extended it, long int, you can say. Okay, so int is not sufficient for this kind of number. Okay, as simple as that. I'm talking about this result. Okay, the direct input that you're getting, okay, that is obviously going to be integer. You can store it in an integer. Even 10 power 9 you can store in an integer. But the operation that you're seeing, right, it is going to be 3 into 10 power 9 in the worst case. That cannot be stored in an integer. Okay, so let us quickly see what we are doing here. So first of all, I'm calculating the length of the given input. Then I'm calculating my answer, which I'm initializing with 0. Okay, then I'm taking a priority queue. Remember, what is a priority queue? Basically, see, the idea here is, see, you can basically sort. Okay, if you see each step here, what you can do is, obviously, after each addition, or let's say in the starting itself, you can sort, take the smallest two, calculate this value, add it back, sort again, and keep repeating it till you see that all the elements are greater than equal to k. You can do that. But remember, the idea here is we do not need everything sorted. We only need the smallest value. Okay, remember, it doesn't matter what other elements, how other elements are arranged. Okay, it doesn't matter. I only need the smallest value. Okay, so instead of spending n log n time for each sorting, what we can do is we can just spend log n time to get the smallest value. Okay, obviously there is a difference here. You have to spend n log n time, then everything will be sorted, and then you will get the smallest value. Otherwise, you can use a heap or a priority queue, which will give you the smallest value without sorting everything. Okay, it will not sort everything, it will just maintain a tree structure. Because of that, it is able to give you the smallest value, and that will take log n time. Okay, so obviously there is a difference. Log n and n log n, both are different, right? So instead of sorting, we can go for the log n approach, which we can get using priority queue or a heap. Okay, so I'm taking priority queue. The elements in this are going to be long. Okay, as I mentioned, obviously, see, this is going to store the results. Okay, the final calculated value will store here. That's why it's going to be long, not an integer. Okay, I'm calling it as a min heap. Remember, the default implementation is always going to be minimum heap. Okay, now is equal to new okay, yeah, fine, that's all right. Yep. Next, then what I'm doing is I'm going through all the numbers. Okay, I'm iterating them using a long variable, and then this variable I'm inserting in my min heap. Okay, this is basically the insertion part. All the elements will be inserted here. Okay, fine. Then starts our real calculation. By this point, our heap will be fulfilled. Okay, heap is like filled with all the elements. Now start the most important part. Still, okay, till the heap is not empty, do this, like, go to the next iteration. What we are doing a poll. What is a poll? Basically, poll means it is removing the top. Okay, that is, it is removing the smallest element out. Okay, you can call it like a heap pop. Okay, it is popping out the smallest possible element in the among all the elements in the heap. Okay, as simple as that. So this will pop the smallest element. Okay, x is going to be the smallest element. Then we are just checking if x is greater than k or not. Remember, if the smallest element itself is greater than equal to k, that means all the elements are going to be greater than equal to k. For that reason, we can break. Okay, we can break. If the, let us say, this is not the case, that means we will have to go for this operation now. So we are again doing a pop to get this second smallest value. Remember, among x and y, x is going to be the smallest, y is going to be slightly okay, y can be equal to x or it can be greater than x. Okay, as simple as that. But we have to generally think that x is going to be smaller than y, or it can be equal to y also. Okay, as simple as that. So this is going to be a second smallest element. And then we are doing this calculation. Okay, smallest value into 2 plus the second smallest value. Okay, it is going to be 2 into x plus y. Okay, as simple as that. This value will now be inserted into the heap. Okay, so two elements were removed, and in place of them a single element was inserted. Okay, since we have done this whole operation now at this point, that's why we're doing answer plus 1. Remember, had we broken out from here, we would not have incremented the answer. Okay, since the operation was not done, so we would not have done the increment of the answer. Okay, but since we have done all these three steps, okay, popping x, popping y, and then inserting the calculated value, that's why we are doing answer plus 1. Okay, this will keep continuing. Okay, till the size of the heap is not 0, or we are breaking from it. Okay, these are the only two places where this loop can break. Okay, as simple as that. And finally, we are returning the answer. Okay, let me quickly show you some of the print statements. See here, let us talk about example number 1. If you see in this case what is happening, the smallest value are going to be 1 and 2. Okay, so you see, this is how the heap is going to look like. Okay, so this is how the heap is going to look like before starting any, before, see, you see the print statement where it is. Okay, it is here. I have computed currently, but yeah, if it is here, so by the time we enter the loop, this will be a print. Okay, this will be printed. So this is the condition after heapifying it. Okay, that is, once we are starting this program, this is going to be the condition of the heap. Okay, as you can see, 3 is here. Okay, remember, not everything is sorted here. Okay, if you see, this is not the sorted in order, but it ensures that the smallest value is always there in the 0th element. Okay, heap means it will always keep the smallest element in the 0th index. That is the only thing that is guaranteed. Okay, nothing else is guaranteed. So you see 3 is here, 10 and 11 are before that. Okay, so these are not arranged in a sorted way. That is the best part about heap. It will always return the smallest value only. Rest of the things is not guaranteed. Okay, the other arrangement of the elements, it's not a guaranteed way that always it will be sorted. Okay, as simple as that. So what will happen now, 1 and 2 will popped out. In place of 1 and 2, what will be inserted? It will be 2 into 1 plus 2. Okay, which is 4. So these three elements will remain and 4 value will be inserted, and then it is going to look like this. Okay, now see, after these two are popped out, the next smallest value is going to be 3. So 3 will be here. Okay, 3 will be always in the 0th place because it is the smallest. Okay, in next step, okay, since again all the elements are not greater than equal to 10, so we'll go to the next step. So 3 and 4 will now be, we'll be doing this calculation now. Okay, so it will be 2 into 3 plus 4. Okay, which is 6 plus 4, which is 10. Okay, so we'll have two 10 values now. As you can see, again, this is not sorted, as you can see, but the smallest value is here in the 0th place. Okay, at this point, as you can see, all the elements are greater than or equal to 10. So we only needed two operations. Okay, that's why the answer is going to be 2. Okay, you can go through some of the other outputs. Okay, you can go through that, and if you see case number 3, that is something that I have included on my own. This is the exact case where it will be crossing the integer limit. Okay, had I not taken as a long, you will see a negative value in one of your calculations. Basically, okay, you will see a negative value appearing in one of your intermediate details. So that is the reason why I have taken long. Okay, so if you want, you can take this test case. This is the exact one where basically it will be crossing the integer limit while calculating one of the intermediate results. Okay, and yep, same is the case here. Okay, this is also one of the case where it will be crossing the integer limit. Maybe like I can give these things in a comment section if you need them. But again, like I have just taken them from one of the test cases only. Okay, as simple as that. So yeah, and that for this solution. Okay, let me show you the Python equivalent of this now. See, Python means it's a very chill language. Okay, you don't have to do anything much. Here we have to decide on integer, we have to decide on long and all that. But if you see in Python, there is no such worry. Okay, exactly, we are doing the same thing. We are calculating the length, we are taking the answer, we are using heap in this case. So basically, see, here what we did is we are inserting every element into the this particular heap. But in the heap q library, we have a heapify function. Okay, this is much efficient than that. See, what is happening here is you are going through all the elements and then you are inserting them. Okay, so each insertion will take log n time, and we are going through n elements, so it is going to n log n time. Okay, but if you see in this case what is happening, but directly with the o of n time itself, we are able to insert all the elements. Okay, so that is the best part here. Okay, that is the advantage that this library has. Okay, you can insert all the elements at once with o of n time. Okay, as simple as that. Next, again, same thing we are doing here. We are taking the x. Okay, doing the heap pop. See, the syntax is slightly different here because the libraries are different. Okay, that will always be remaining. Okay, here the libraries are different, so it is a different syntax. Here we're using the term pop, but if you see here we are using the term poll. Okay, as simple as that. Similarly, here we are using the term add, but here we'll be using the term push. Okay, heap push, and this is heap pop. So we are doing heap pop to get the x. If x is greater than equal to k, that is, if the smallest element itself is greater than equal to k, break out, do not continue further. If that is not the case, pop the second smallest element. Once you have the smallest and the second smallest element, do this calculation. Okay, that's what we are doing it here. As you can see, we are doing this calculation, and this will be inserted. So since all the three operations are done, so that's why we'll incrementing the answer by 1. Okay, this will keep continuing till this condition is satisfied or this condition is not satisfied. Okay, only these are the two breaking cases. After that, we'll return the answer. I can show you, like, as you can see, displaying all the test cases. Okay, yep, this was the solution. If you talk about the space and time complexity here, as I mentioned, see, adding itself will take n log n time. Similarly, like, see, on the overall basis, let us see, each element will be inserted once and each element will be popped once. Okay, that is what it will happen. Okay, so overall it will take n log n time. And if you talk about the space complexity, mm, yep, it will be O of n, because see, always something will be popped out, something will be inserted in its place. Okay, for every two element, a single element will insert it. So on the worst case, it should be O of n. Okay, space complexity should be O of n, and time complexity will be O of n log n. Okay, as simple as that. So yeah, friend, that was all for this particular video. I hope you enjoyed my solution, and I am definitely sure that this is the something that you might have learned and you might have found this interesting. This is very important. If you can show this kind of calculations, this will make a lot of sense in front of the interviewer, because remember, everyone can code these days, but it's all about how much mind you are applying to the code. Okay, see, always there should be reason behind your operations, why you are taking long and why you're not taking int. If something can be done with integer, okay, even considering the worst case, if you can do with integer, then you should be going for integer only. Okay, otherwise it will take a lot of extra space. So that is what it is. If you can prove that, okay, in the worst case it can cross, as I have proved that, see, by very minor will it is crossing. Okay, had it been 29.48, we would not have needed a long. Okay, integer would have been sufficient, but since it is crossing 31, okay, we will have to take a long. Okay, I've also shown you some test cases where it will be, number will coming negative. Okay, the calculation of this, okay, stuff will be coming as negative because it is crossing the int limit. It is basically, applying a value to that sign bit, that 31st bit. Okay, it is applying a value. Okay, since if you see till 31 bit is fine, the 32nd bit basically. Okay, if you take the 0th index, it will be 31st bit. It is a sign bit. Okay, if you assign a value there, it will be basically getting converted to a negative number. Okay, it will appear as a negative number after that. So you have to take those cases into consideration. Okay, so often that was all for this particular video. If you like my efforts, if you get to learn something new, or if you like the quality of this content, please do subscribe to the channel. This really gives a lot of motivation to continue further. This is my 114th day, and hope you are enjoying my solution. There are a lot more days to come and a lot more topics to come. So see you tomorrow. Thanks a lot.